Okay. Question number 22, page number 6. Three 2-volt cells are connected in series and used as a battery in a circuit. Three 2-volt cells are used. One 2-volt cell, two, and three 2-volt cell. 2, 2, 2. Okay, they are connected in series. So what will be the total voltage? 3. 2 plus 2 plus 2, that is 6. So if they are connected in series, the total voltage is simply added up. Okay, what will happen if they are connected in parallel? What will happen? What will happen if the cells are connected in parallel? Tell me. If three 2-volt cells are connected in parallel, what will happen? What will be the voltage across its terminals? This is A, this is B. What will be VAB? Tell me. If they are connected in parallel, what will be VAB if they are connected in parallel? Tell me. No, that will be 2 volt only. Yes, because if it is 2 volt, this terminal is 2, this terminal is 0. This will be 2, this will be 0. Similarly, this will be 2, this will be 0. This will be 2, this will be 0, right? If it is 2 volt each, then this will be 2, this will be 0, right? So that means A terminal will always be at 2 and B terminal will always be at 0. So VAB will be 2 volt. I'm
just saying that.
So
you are just giving the AB, right?
VAB. So if B is always at 0, A is always at 2, what will be the difference? 2 minus 0, that will be 2. Okay. And if it is connected in series, it will be E1 plus E2 plus E3, right? So if it is 2, that will be 2 plus 2 plus 2, that will be 6 volt. Okay. So first answer done. So if they are connected in series, it will be 6 volt. Okay, how many joules of electrical energy does 1 coulomb gain on passing through one cell or 3 cell? Now, part 2 says how much energy it will gain. So we know W equals to Q times V. Now if it passes through one cell, that is through 2 volt, and Q equals to 1 coulomb, then work done will be Q into V, that is 1 coulomb into 2 volt or 2 joule, right? Are we clear? Now second point is, if it passes through the entire battery, so what will be the voltage? That is 6 volt. What will be the charge? 1 coulomb. So what will be the work done? Q into V, that is 1 coulomb into 6 volt, that will be 6 joule. Are we clear about it? Okay, done? Write down. Okay, page number 11, question number 23. If the charge on an electron is 1.6 into 10 to the power minus 19 coulomb, how many electrons should pass through a conductor in 1 second to constitute 1 ampere current? Okay, so for 1 ampere, tell me how much charge will pass to constitute 1 ampere current? Tell me. First tell me that. How much charge will pass to conduct 1 ampere current in 1 second? Tell me. 1C. So we know this is question number 23. Okay, page number 11. Okay, we know current equals to charge by time, right? So it has been given to us that the current amount is 1 ampere and the time is 1 second. Current amount is 1 ampere, time is 1 second. So can we write 1 into 1, that will be 1 coulomb? Now we know that 1 coulomb can be written as N times E, because this is the smallest amount of charge, right? This is the smallest amount of charge, and the value of the smallest amount of charge is 1.6 into 10 to the power minus 19 coulomb, right? And what is N? Can anyone say anything? What is N? What is N? N is the number of electrons. N is the number of electrons. So 1 coulomb will have N number of electrons, and charge of 1 electron is this much, right? Okay, so now we want to find out the value of N. They are asking this only, na? How many number of electrons will pass through a point to conduct a current of 1 ampere in 1 second, that is to pass 1 coulomb amount of charge, right? 1 ampere current in 1 second, that means how much amount of charge it will pass? 1 coulomb amount of charge. Are we clear about this? Okay, so for 1 coulomb amount of charge, there are N number of electrons required. So N will be 1 coulomb by the charge of an electron, that will be 1 coulomb by 1.6 into 10 to the power minus 19 coulomb. Are we clear about it? Okay, if we cut down this one, this will be 6.25 into 10 to the power 18 number of electrons.
Sir, the last part will just repeat again.
N will be C by E, charge of an electron. Charge of an electron is this much. So if I divide it by this much, we will get this as the value.
Sir, why we divide that?
Why we will divide that? Okay. See, 1.6 into 10 to the power minus 19 is the charge of how many electrons? 1.6 into 10 to the power minus 19 coulomb is the charge of how many electrons? Okay, so this is the charge of 1 electron, right? So 1 coulomb is the charge of how many? How shall we find out? 1 by that much, absolutely. So that will be 1 by 1.6 into 10 to the power minus 19. This much electrons. That is what we have done here, and this is the value. Done? Are we clear? Okay, write down. Okay, question number 26E, page number 12. A flash of lightning carries 10 coulomb of charge which flows for 0.01 second, right? What is the current? Again, current bar kori. First let us find out the current, then we will think about the other things. Okay, now first we will find out the current. Okay, what is the total amount of charge they are saying? 10 coulomb. Okay, and how much time is it taking to flow? So 10 coulomb of charge. So Q equals to 10 coulomb. Time taken is 0.01 second. Okay, how do we find the current? I equals Q by T, right? So that will be 10 coulomb by 0.01. That will be 10 to the power 3 ampere. Okay, so this is the amount of current. Now what are they saying? If the voltage is 10 millivolt, what is the energy? They are saying if the voltage is 10 millivolt, if the voltage is 10 millivolt, what is the energy? See, we know W equals to Q times V, right? They are saying voltage is 10 millivolt. No, that is megavolt. Sorry, it's megavolt. Okay, MV is megavolt. So 10 into 10 to the power 6 volt. Okay, now W equals to Q times this. Q is 1 coulomb. 1 coulomb or 10 coulomb? 10 coulomb. So 10 coulomb into 10 to the power 7 volt. 7, 10 into 10 to the power 6, 10 to the power 7 volt. So that will be 10 to the power 8 joule. Are we clear? So work done is 10 to the power 8 joule. Write down. Okay. Page number 12, question number 33. Draw a circuit diagram to show how 3 bulbs can be lit from a battery so that 2 bulbs are controlled by the same switch while the third bulb has its own switch. 2 bulbs will have same switch, third bulb will have its own switch. 2 bulbs will have the same switch, third bulb will have its own switch. Okay, and all of them has to be lit, right? All of them has to be lit. Okay, just let me see one more time. Draw a solution that 3 bulbs can be lit from battery so that 2 bulbs controlled by same switch, third bulb also. Okay, so we have 3 bulbs. Okay, now can we place a switch in here and can we place a switch in here? Now what if we connect these ends? Will this work? Will this work? So 1 bulb is controlled by switch 1, 2 and 3 number bulbs is controlled by switch 2. Okay, so circuit diagram is complete. Okay, question number 34. An electric heater is connected to a 230 volt main supply. 230 volt main supply. A current of 8 ampere flows through the heater. So this is question number 33, right? No, the next one is 34, which we are doing now. 34 says that electric heater is connected to a 230 volt main supply. So V equals 230 volt, right? 230 volt main supply, and A current of 8 ampere flows through the heater. So what is the current amount flowing? A current of about 8 ampere is flowing, right? So current of 8 ampere is flowing through the heater. How much charge flows around the circuit each? Okay, if 8 ampere current flows, so how much coulomb of charge is flowing?
Into 8.
Huh? Why 230 into 8? I is 8 ampere. They are asking about the charge flowing, right? Charge flowing.
Divide by 8.
No. I equals to Q by T, right? So what will be Q? Q will be I times T. Q will be I times T. So if T is taken as 1 second, as they have told there, and I is 8 ampere, this is 1 second. So what will be Q? Q will be 8 coulomb. So amount of charge flowing per second will be 8 coulomb. Okay, that will be 8 coulomb. Okay, next is how much energy is transferred to the heater each second. How much energy? See, the amount of work done is equal to the amount of energy required, right? We know work done W equals to Q times V. So this is the amount of energy required, right? If we need to do a work, we require energy. So if W amount of work has to be done, so W amount of energy is required. Suppose I am walking up the stairs, I am going to the first floor. So if I go to the first floor, I am doing some work. For that I need some energy. So the amount of work I will do, the same amount of energy I will be required, right? So W equals to QV, this is the amount of energy which we need. Or, so Q is 8 coulomb. So they are talking about how much energy required per second, right? So Q is 8 coulomb, so that will be 8. V is 230 volt. So 8 3s are 24, carry 2, 8 to the 16 and 4 20. 16 and 2 18, right? So that is 1840 joule. So this is the amount of energy required. Done? Okay. Are we clear? See, the thing here is they have told the amount of energy required in 1 second. What will happen if they tell what is the amount of energy required in 5 seconds? How will we do that?
I'll just input the 1 second into 5 minus 8. 8 by 5.
Okay. So if they are telling that what is the
5.
in 5 seconds, right? So charge will be T will be 5 here. So we will get 40 here. We will just put 40 in here. Oh, that is a process. This is a good process. We can do it in this way. So first we will find out the total charge. Then just we will find out the amount of work done. This is a process. Another process can also be there. Suppose for 8 coulomb charge. For 8 coulomb charge, that is for 8 ampere current flowing, we are getting this much energy used up in 1 second. So how much energy will be used up in 5 seconds? 1 banana costs 2 rupees. 5 banana will cost 2 into 5 rupees. So this is the amount of work done or the amount of energy required in 1 second. So how much amount of energy will be required for 5 seconds? Times 5. Are we clear? Are we clear about this? Okay. Okay. Page number 18. Question is, state which has less electrical resistance, a thin wire or a thick wire of the same length and same material. See, we know R equals to rho L by A, right? Okay, what is A? Okay, A is area of cross section. A is area of cross section. Okay, what is L? L is length of the wire. L is length of the wire. Rho is known as resistivity. What is rho? Rho is known as resistivity. Suppose we are taking a cylindrical section of a wire. Okay, how is a wire? If you zoom a wire, if you cut a wire, will it be like a cylinder or will it be like a rectangle?
Cylinder.
It will be like a cylinder. Anywhere if you cut them, it will be like a cylinder. Okay. Now that wire has a length. We will call this length as L. Okay. If we cut it and make a transverse section, this will be the area. What will be this one? Area. What is resistivity? Resistivity is an internal property of the wire. What is resistivity? It is an internal property of the wire. Suppose copper has a type of resistivity, tin has a different type of resistivity, tungsten has more resistivity, okay, nichrome also has more resistivity. So there are various kind of materials, so every material has its own type of resistivity. So resistivity is an internal property of the material that depends on various types of metal, okay. So this is resistivity. Now we know that R is proportional to 1 by A, right? If the area increases, resistance will decrease. If the area will decrease, resistance will increase, right? Are we clear about this one? Okay. Now they are saying that there are two wires. One is a thin wire, one is a thick wire. Let me draw a thin wire first. Let me draw a thin wire. This is a thin wire. Okay. This one is a thin wire. And if I draw a thick wire of the same length, Shiny, tell me what is the difference between a thick wire and thin wire? Tell me. Are their length different? Are their length different? No, Shiny only tell. Are their length different? Are their length different? No. See, this is also having a length L. This is also having a length L. Are we clear about this? Okay. Both of them are made up of copper. So if both of them are made up of copper, both of them will be having the same resistivity. So they are having same resistivity. What is different? Area is different. Okay, in which case is the area more? Thick wire or thin wire? In thick wire. So in this case area is more. So if area is more in this case, what will be the value of resistance here? Less or more? If area is more, the resistance will be less, okay. So R proportional to 1 by A, so resistance will be less when area will be more. Question number 8 is saying that keeping the potential difference constant, the resistance of a circuit is halved. Potential difference is constant, okay. So what is the idea of potential difference? First tell me this one. Potential difference. What is the idea of potential difference? Tell me. What is the idea of potential difference? The question is said that keeping the potential difference constant, the resistance of a circuit is halved by how much does the current change. See, this is the initial circuit, okay. This is the initial circuit. Okay, now in this circuit we have a resistance here, okay. This is the potential difference. Suppose a potential difference of V volt is applied. How much voltage? And resistance is capital R. Okay. Potential difference of V volt is applied. Potential difference of V volt is applied, and the keeping the potential resistance of the circuit is halved by how much does the current change. So V is constant. What is halved? Resistance is halved. So this is the first case, okay. This is the first case. Now if we see the second case, what we say that the resistance is halved. So the new resistance is R by 2, right? So if it is R by 2 and the voltage is same, the voltage is V, they are asking what is the current in this case if it is I1, and what is the current in this case if it is I2. Can you tell me? From Ohm's law, what do we know? V will be equal to IR, right? So V will be equals to I1R. Okay, in the second case, V will be equals to I2 into nu R. What is nu R? R by 2, right? Now, voltages are the same. So can we equate both of them together? So can we say that I1 into R will be I2 into R by 2? Can we say that? Or if we make a ratio I2 by I1, can we say that will be R by 2 by R? So that will be half. Or can we say that I2 will be equals to half of I1? Are we clear about it? Write down. Okay. An electric circuit consists of a 0.5 meter long nichrome wire XY. Okay, nichrome. Okay, can you tell me in which kind of substances nichrome is used? Nichrome is used in which kind of substance? Resistor. Obviously nichrome is used in resistor, but which kind of places we use nichrome? which kind of places do we use nichrome? We use nichrome in heating elements. Where do we use them? Heating elements. Okay, so we use nichrome wires in heating elements. Okay, now we use them in heating elements. So they are saying that a voltmeter, 4 cells of 1.5 volt each, and a plug key was set up. 4 cells of 1.5 volt. How will it be arranged? In series or in parallel? In series. Why do we place them in series? Why don't we place them in parallel? Anyone? Why don't we place them in parallel? Why do we place them in series? Why don't we place them in parallel? Because if we place them in parallel, how much voltage are we getting? If we place 1.5 volts in parallel, how much voltage are we getting? 1.5. If we place them in series, how much are we getting? 1.5 into 4. So that will be 6 volt, right? Okay. So what they have told us is we have a 0.5 meter, right? A 0.5 meter long nichrome wire. Okay, we have a 0.5 meter long nichrome wire and an ammeter, a voltmeter, 4 cells of 1.5 volts. So we have one ammeter, we have one voltmeter, and we have 4 cells of 1.5 volt. Obviously we will connect them in series, so we will get 4 times of 1.5 volt, that is we will get a 6 volt of voltage, right? We will get a 6 volt of voltage. Now what they are saying is that draw a diagram of this electrical circuit to study the relation between potential difference maintained between the points x and y and electric current flowing through xy. Okay, so what is x and y? Nichrome wire is xy. Now if it is xy, then this point may be x, this point may be y, right? So how can we place them? We can place them in this way. This is the nichrome wire. Okay, ammeter. Okay, ammeter is connected in series or is it connected in parallel? Ammeter is connected in series or parallel? Series. Ammeter is always connected in series. Voltmeter is connected in series or parallel? Parallel. So voltmeter is connected in parallel. Are we clear here? Okay, and we have a battery. Each of the battery, there will be 4 batteries, 1.5 volt each, right? So this is the battery. So this is a circuit connection. Okay, this is question number 1. This is the circuit connection. Next they are saying that following the graph was plotted between V and I values. So we have a graph here. Just wait for 1 second. Okay, so these are connection. Now they have given us a figure, they have given us a graph. What would be the values of V by I ratios when the potential difference is 0.8 volt? Okay, I cannot show the graph, but when V equals to 0.8, can we say that when it is 0.8 the value will be around 3 point something? Can we say that? Can we say that? There's a peculiar kind of graph given. See, this is the graph. Okay, I don't know if I'll be able to make that. This is 1.6, this is 1.5. okay, and we have 1 here, we have 0.5 here, this is 0. Okay, 0, 0.2, so this is 0. For 0.5, I think for 0.5 we will get 0.1. If it is 0.1, 0.2, 0.3, 0.4, 0.5. okay, if it is in this way, then for 0.5 we are getting here 0.1, then for 0.2 we will get 1, 0.3 we will get 1.5. I think the graph is in this way. Okay, as far as I am seeing that. Okay, V by I values when the potential difference is 0.8 volt. Potential, this is current, this is voltage. Okay, this is current. Okay, if I look at this graph, this is V by I, right? Okay, so if it is V by I, we are told to find out the V by I ratio, right? It is a straight line. What kind of line is this? It is a straight line. So can we say for a straight line V by I is constant, as I told you last day also? So V1 by I1 will be V2 by I2. Are we clear about this? V1 by I1 will be V2 by I2. Now for 0.5 the I is 0.1, right? So if we put V1 as 0.5 and I1 as 0.1, and they are telling us that for V2 equals to 0.8, we need to find out. So we need to find out the value of I2, right? So can I put all of these three values in this equation and find out the value of I2? So if we put them, what we will get? So 0.5 by 0.1 will be V2. V2 is 0.8 by I2, right? Cross multiplying, we get I2 equals to 0.8 by 5. Can I write them? Okay, so we will get them as 50. So 5 ones are 5, carry 3, 6. So that is 1.6 by 50, right? 1.6 by 50, that will be 0.16. Write down. So that will be 0.1. We can also see it here. See, if it is 0.8 and if we drop them down here, that will be around 0.16. Right? Are we clear about that? Write down. For this case we found out I2, right? So what will be V2 by I2? V2 by I2. What is the value of V2? What is the value of V2? V2 is 0.8. What is the value of I2? I2 is 1.6, right? Now 0.16. I2 is 0.16. Okay? So if we cut them out, this will be 10, this will be 2, that will be 5. So V2 by I2 will be 5. So V2 by I2 will be 5. Are we clear? Okay. Next they are saying that similarly what will be the values at 1.2 volt and 1.6 volt respectively. So in the same way, can we find I3 at 1.2 volt? Can we find them? In the same way, can we find I4 at 1.6 volt? Same way. Okay, because V3 is 1.2, we will put V3 there, we will find I3. I4 is for I4, V4 is 1.6, we will put there 1.6 and we will find I4. Can we do that? Okay, and again we will find the relations. We will see that in each and every case we are getting 5. So what does that imply? That implies that the resistance is not changing, or V by I is always a constant, right? Okay.